Thank you for watching Science TV. This is Ilya Barukcic, Jever, Germany. It's December 2009 after Christ. Heisenberg's uncertainty relation was derived for position and for momentum. Meanwhile, there are analogous relations for energy and time, for action and angle, etc. In general, there is no lack of such uncertainties or imprecisions. Insofar, if we were on the way to refute Heisenberg's uncertainty principle, we would have to refute every single inequality by its own. This does not make any sense. Thus far, let us generalize Heisenberg's uncertainty principle without changing the same at all. It is important to note that the rules and the principles as dictated by Heisenberg himself must stay valid and are still valid. We will only reformulate Heisenberg's uncertainty principle, but not change the same at all. Thus far, set A as being equal to sigma of x, set B as being equal to sigma of p, set C as being equal h divided by 4 times p, we obtain straightforward the general form of Heisenberg's uncertainty principle as A times B is greater than or equal to C. This general form of Heisenberg's uncertainty principle is of very great use, since the other analogous relations for energy and time, for action and angle, etc., must not be refuted by itself. Let us mention briefly that we have not changed Heisenberg's uncertainty principle at all. The same is only reformulated, but not changed. Further, it is important to note that the term C equal h divided by 4 times p is all the time greater than 0 and thus of positive value. C is never equal to 0 or less than 0. A negative value of Planck's constant h is still not known. Insofar, if we divide the general form of Heisenberg's uncertainty principle by the term C, we don't make any mistake. We are not dividing by 0, we are not dividing by something negative. We obtain the next result. Once again, let us note that the term C equal h divided by 4 times p is all the time greater than 0. Insofar, the same term is all the time of positive value. Insofar, it is possible and allowed to divide the inequality a times b greater than or equal to c by C itself without making any mistakes. C is different from 0 insofar we obtain C divided by C. This is equivalent to 1. We obtain the next non-strict inequality. A divided by C times B is greater than or equal to 1. Well, it is important to note that our starting point is of course that Heisenberg's uncertainty principle is generally valid. Why this? As mentioned before, Heisenberg stated at the end of his paper that his principle of uncertainty has refuted the principle of causality. Insofar, the same must be generally valid. There are no circumstances where Heisenberg's uncertainty principle must be regarded as invalid. If this is what our world is grounded on, well, what are the consequences? Thus far, let us take a look what happens. How does Heisenberg's uncertainty principle behave under special circumstances? Are there circumstances where the same may break down? Let us set B as being equal to 0. What happens under these circumstances? Theoretically, it is not possible or allowed that Heisenberg's uncertainty principle breaks down under circumstances where B is equal to 0. Heisenberg has not excluded this case. He has said, the principle of uncertainty has refuted the principle of causality. Insofar, my principle of uncertainty is generally valid. The same is valid if B is equal to 0. What happens if we set B being equal to 0? We get the following result. A divided by C times B, which is now equal to 0, is greater than or equal to 1. We have changed nothing. We are still talking about Heisenberg's uncertainty principle and his uncertainty relation. We have only set a value inside his inequality and are looking how does the same behave under special circumstances. Well, we are multiplying something with 0. This is a mathematical operation which is allowed. The result is A divided by C times 0 is greater than or equal to 1. Well, if we multiply A divided by C times 0, we obtain 0. Insofar, the result of our proof is, at the end, 0 is greater than or equal to 1. This is the foundation of Heisenberg's uncertainty principle, and since the same is generally valid, this is the foundation of our world. This is what our world is grounded on. If we accept Heisenberg's uncertainty principle as generally valid, we must equally accept that either 0 is equal to 1 or 0 is greater than what? Which is a contradiction. We are able to derive a logical contradiction out of Heisenberg's uncertainty principle. At the beginning of his paper, Heisenberg stated that logical contradictions cannot be accepted. Insofar, Heisenberg himself cannot accept his uncertainty principle at all. Insofar, the opposite of our assumption must be true, or Heisenberg's uncertainty principle is not generally valid. The same is refuted and not of any value at all. Well, some of us will remember Popper, the one in a positive, the other in a negative sense. Karl Popper developed a principle of falsifiability to use the same as a weapon against some theories. The last word is not said on Popper's principle of falsifiability, but the same can be used under certain circumstances. If we rely on Popper's principle of falsifiability, only one single counterexample can show Heisenberg's uncertainty principle to be false. We have shown an example above. In the case of 0, we have demonstrated that Heisenberg's uncertainty principle is wrong. The same is incorrect. Insofar, Heisenberg's uncertainty principle is not compatible with classical logic and is not of any value at all. Heisenberg's uncertainty principle is refuted. Thank you for watching Science TV. This is Ilya Barukcic, Jever, Germany, December 2009. Bye bye.